The focus and directrix definition of a parabola actually gives us a very powerful application of parabolas. So one very cool feature of parabolas is this. Let me go ahead and draw focus and vertex. And again, I'm not a great artist, but this is what we have with our focus and parabola. There's a very cool feature that we have that if you travel from the focus to a parabola, okay, then when you hit the parabola, it's always going to bounce off. Like if we look at bounce off that barrier, and the angle here and here is equal, okay? It's always going to go straight out perpendicular to the directrix. Okay, the directrix is down here. Always goes straight out from that. And it doesn't matter where that is. Let me go ahead and do another one. Okay, right there, it comes and it bounces off straight out. Okay, which is a very powerful application of parabolas. So parabolic shapes are used often for, they're used for satellites, because if you think about a satellite, and I'm not an artist, but if you think of a satellite, you've got a dish, okay, and generally there's this thing that like comes out, okay, and there's like a receiver right there, okay, and the reason is that receiver is placed at the focus. I'm sorry, this is like, I'm really bad. Okay, if this is, pretend this is my my satellite. Okay, that receiver for the satellite is at the focus of the parabola. So when signals come down, straight down, they bounce into the focus, and then you collect the information. So that is a very powerful application for parabolas. Let's do an example. A satellite dish is to be constructed in the shape of a paraboloid. This just means it's three-dimensional. Okay, paraboloid. If the receiver placed at the focus is located 2 feet above the vertex of the dish, and the dish is to be 12 feet wide, how deep will the dish be? So let's sketch this, and I'm just going to sketch it as if it's going upward. So, and it doesn't really matter where we place the vertex here. I'm going to place it at 0, 0. Keep it simple. And we know the receiver placed the focus is 2 feet above. So here is our focus. And we have a parabola. And all we know is that the dish is 12 feet wide. So I know I'm going from -6 to +6. Okay, and I would just like to know how deep it is. In other words, what's the y value over here? Now, this is a parabola opening upward, so we have x squared equals 4py, but we know that p is 2. So x squared equals 4 times 2, which is 8, times y. And now I can plug 6 in for my x, or -6, doesn't matter, and I get 36 equals 8y. And then I can solve for y. Divide both sides by 8, and we get, if we want to reduce, 4 can go into both of those. That's 9 halves. Y. And so that is that's the distance from the axis up to that point, which is the depth of the satellite. That's 9 halves. Okay, so 4.5 feet is the depth of this satellite dish.